Hey guys, today we're looking at 9.1 Day 2's notes, which is extending right triangle trig. Now that we've established what the 6 trig functions are and how we evaluate them using a right triangle that's given already to us, today focusing on, we'll talk a little bit about special right triangles, special angles that we'll utilize more so moving forward, but it is also useful for us today. And then focusing on finding missing sides and what we call solving a triangle, so finding all the missing sides and angles. So here in box 1, this is our special angles. So like I had touched on yesterday, we have a couple of different special right triangles. Yesterday I talked about Pythagorean triples with side lengths that always give me a right triangle. With these two triangles in particular that we're looking at, and these 3 special angles, they happen very, very commonly in nature, and they're nice values that we work with quite a bit. When we get to the unit circle in a couple of sections, we'll kind of revisit these, and they're going to be very important for us to know what those values are. So the 2 special right triangles that we deal with that have special relationships between their side lengths and their angles are a 30-60-90 right triangle and a 45-45-90 right triangle. So the 45-45-90 triangle, obviously that's isosceles. So we've got, the 2 legs are exactly the same. And then with my 30-60-90, I've got a special relationship between my short leg, my long leg, and my hypotenuse. So these values that I have here are just assuming that kind of the most common thing is just 1, because what you might have learned in geometry, if we look at, again, just a sketch here of a 30-60-90, we knew that the short leg is kind of what I establish it as, just x. That makes my hypotenuse twice that length. Right, my short leg times 2 is my hypotenuse, and then my long leg is just whatever that short leg is times the square root of 3. So that's that special relationship that's always the case with a 30-60-90. It doesn't matter, what the orientation is or how big or small it is. If it's a right triangle that has 30 degrees in one corner and 60 degrees in the other, the short leg times 2 is the hypotenuse. The short leg times the square root of 3 is my long leg. So I've got that relationship. And here, like I said, up above, we're just assuming that my short leg is 1. So if I double that, it gives me 2 for my hypotenuse. If I multiply it times the square root of 3, that gives me square root of 3, because 1 times square root of 3 is just square root of 3. So those 2 angles, 30 degrees and 60 degrees, are on this top row and bottom row of my table here. Now I'm only going to highlight sine, cosine, tangent. Like we did in day 1 of 9.1, we realized that the 3 other functions are just the reciprocals. So not as important for us. And actually, when we get to the unit circle, it's just sine and cosine that are the most important ones. Those are the 2 that show up in the unit circle. So all we're doing here to find these values that's in this table that's going to be available to you is going to be a quick reference thing for you until we get to the unit circle. It's just taking those relationships that we looked at yesterday with sine being opposite over hypotenuse. I'll rewrite it here for us with TOA. Right, sine is just the opposite over the adjacent, the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and then tangent is the opposite over the adjacent. So all we're doing here for 30 degrees, if we say that this is our theta, that means the opposite is 1, the hypotenuse is 2, so that's where the 1/2 comes from. The cosine would be the adjacent over the hypotenuse, so square root of 3 over 2. And then my tangent is the opposite over the adjacent, which would be 1 over the square root of 3. And here in the table, like we did yesterday, we just rationalize that so I don't have a square root in the denominator. So that's all that's happening there in my table for 30 degrees and for 60 degrees is just from that triangle. And then my other right triangle, my other special right triangle, is an isosceles right triangle, which means my 2 angles are 45 degrees, and then obviously I have 90 degrees in the third corner. And with those, my side lengths were always the same. For my 2 legs. If I make a 45, 45, 90, and just assume that that's actually a 45 degree angle. Back in geometry, when you're learning those special right triangle relationships, the legs obviously are the same since this is isosceles. It's also 45. But now the special relationship between that third side is that it's just my, whoops, didn't mean to do that. It's just my short leg times the square root of 2. So that's the relationship there. So again, and the one that I'm looking at here is just focusing in on my short legs, or my two legs being 1 unit long. That means that my hypotenuse is the square root of 2. So the nice thing here is that my sine and my cosine are exactly the same because my opposite is 1. My hypotenuse is a half. So is square root of 2. So 1 over the square root of 2, rationalized makes it square root of 2 over 2. And that's the same no matter which one you're looking at. And then my tangent, since it's just opposite over adjacent, the opposite is 1, my adjacent is 1, so 1 over 1 is just 1. Again, don't get too hung up on having these memorized right away. The more you use them, the easier it will be to be memorized. And again, we'll revisit these when we get into the unit circle. I think that's 9.3, where we'll kind of revisit those values. And again, sine and cosine, the most important ones, because we've got other ways of working around getting the other 4 functions, including tangent, as long as we know what the sine and the cosine is. So it's really only 6 values that you'll have to have memorized. All right, so let's hop on into box 2, where we actually start utilizing that information. So box 2 is asking us to find the value for x in the right triangle. So this is getting into solving for different pieces of my triangle, given side lengths, angles, some combination of those two things. So again, we're going to have to use SOHCAHTOA here, but now I don't have all 3 of my sides. I actually only have 1 side, so I can't even do Pythagorean theorem to find that third side. But what I am given here is that 30 degrees in my triangle here. This small angle on the right side is 30 degrees, which means I know the ratios, the values of those trig ratios in a 30-degree angle, or of a 30-degree angle. So when I'm looking to figure out, solve for missing pieces, find missing sides, I'm still going to pick a value, like pick an angle to be my theta. Obviously, this one that we're given here is going to be my theta. So 30 degrees is going to be my angle that I'm focusing on. And I'm going to go ahead and label my opposite, my adjacent, my hypotenuse. So from 30 degrees, this would be my opposite, this would be my adjacent, this is my hypotenuse. So in this case, x is my adjacent side, 12 is my hypotenuse. So I need to figure out which of my 3 trig functions involves the opposite side, the adjacent side, since that's x that I'm looking for, and the hypotenuse, which is the 12 that I'm given. I know those 2 pieces of information. So in this case, adjacent and hypotenuse, if I peek back over to SOHCAHTOA, adjacent and hypotenuse work together in cosine. Cosine is equal to the the adjacent over the hypotenuse. So what I'm going to do here, I have to set up an equation, because I know that cosine of 30 degrees is equal to the adjacent over the hypotenuse. So just in general, just generically speaking, cosine of any angle, theta, is the adjacent over the hypotenuse. And we had that written directly in our notes in box 1 for day 1, for 9.1 day 1 yesterday. So all I'm doing here is replacing the 2 things that I know and the third thing that I want to find. So now the cosine of 30 degrees is equal to x, which is the adjacent side, over 12, which is the hypotenuse. So from here, it's up to you on what order you want to go in. We want to solve for x, so I'd work on getting x by itself first before I do any kind of substitution of values. So to get x by itself, we multiply by 12 on both sides. 12 times cosine of 30 degrees is equal to x. And now we know what the cosine of 30 is. We can find it in the table over there on the left side. Cosine of 30 is just square root of 3 over 2. So 12 times square root of 3 over 2, and that is equal to x. So now I can just reduce, and I end up with my 12 and my 2 canceling out and giving me just 6 square root of 3. Which I suppose if you wanted to put it as a decimal, you could, but since it's given to us in radical form in the table that we have, I would rather just leave it in radical form. That's the exact value. All right, and since we had to solve for x, that's all I had to do for that one. I don't have to do anything else. I don't have to find the third side or the other angle. That's not what I'm asked to do. That is what I'm asked to do for box 3. Box 3 is asking us to solve triangle ABC, which in order to solve a triangle, we need to know all 3 sides and all 3 angles. So it doesn't matter what order you go in. There's quicker things that you can find and more difficult ones, but there's no set way that you have to do it. It's personal preference. As usual, I'm just giving you tools in your toolbox. You open it up and take out whatever tool you want to use first, or whichever one you're most comfortable with. But if I need to find all 3 sides and all 3 angles, I already know 2 of my angles. I know 90 and I know 28, which we know the two non-90, non-right angle angles, vertices in a right triangle have to add up to 90. So 28 plus 62 degrees would give me 90. So that tells me that angle B is 62 degrees. Let me rewrite that so it's a little bit clearer. 62. Now the only side length that I know is little b, which is side AC. I know that bottom part there. So I'm going to need to do this in kind of 2 separate waves, 2 different stages here. I'm going to need to find what side length C is with the hypotenuse, AB, or I'm going to need to find my other leg, which is side A, which is side length BC. And I can do this a couple of different ways, but again, I know an angle, I know a side length, so we're going to choose one of them that we're given, and just, again, find those trig ratios that utilize the 2 things that I'm needing. So just as a refresher, so that we don't forget, we've got SOHCAHTOA, and if we pick 28 degrees, my suggestion would always be use values that you're given, not necessarily that you've done anything to figure out. So even though I know 62 is correct, I trust myself that I can do that basic math of 90 minus 28 giving me 62. I would suggest using given information. That way you minimize the possibilities for mistakes that you're given. So I know 15 degrees right here, or sorry, not 15 degrees, the side length is 15. And if I'm going to label them as things that I know, from 28 degrees, the opposite side would be over here, my adjacent would be right here, and my hypotenuse would be right there. So if I'm using 28 degrees as my angle, the opposite would be little a, the adjacent would be little b, and the hypotenuse would be little c. So I'm going to choose whichever one I want to solve for first. It does not make a difference. You can solve for the opposite side and then separately solve for the hypotenuse, but it's going to be 2 separate actions. They're not going to be directly related to each other. We're just going to have to use our trig ratios to find those values. So if I wanted to find, let's just say I want to find the opposite side first, so little a. If I'm wanting to use the opposite and the adjacent of 28 degrees, looking at our 3 trig functions, tangent is the opposite over the adjacent. So that would be the trig ratio that finds little a, but uses 15. So I'm going to go ahead and set up that equation. So tangent of 28 degrees is equal to the opposite, which is little a, over the adjacent, which is positive 15. And now that I have that set up, I can just go ahead and solve for a. That's what I need to do, just like I did in box 2. So here I'm going to go ahead and multiply by 15 on both sides. And that gives me 15 times the tangent. I'm going to switch colors here. That's not showing up real well. 15 times the tangent of 28 degrees is what my a value is. Now, that's not one of our special angles, so I'm not sure right now how to handle this. Right? It's not 30 degrees, it's not 45 degrees, it's not 60 degrees, so it's not one of my special ones. So what I need to do is use my calculator for this, which is, what the title of box 3 says. So I'm going to go ahead and grab my calculator that I can throw on screen for you guys. And this is going to be a little bit different because the way that my computer calculator works, it utilizes a different order than what most of ours would be. If you're using one of my calculators in the classroom, the TI-30X2s, or if you've got like a graphing calculator, an 83 or an 84, it's going to be a little bit different. You can just type in sine, cosine, or tangent, and then your number and hit equals. With some other calculators, like I know some people who have like 30As, or I think that's what it is, like 30As or 30Bs. People who usually, like if you know on your calculator, when we did square roots, if you typed in the number and then hit the square root button, you're going to have to do it the way that I'm showing you right now. If you're using a regular calculator like I have that you guys have available to borrow, or if you've got a graphing calculator, you'll do it a different way. So I'm rambling for a little bit. Let's back it up a little and talk about why we're using our calculator. So what our calculators are actually doing here, they're not making any calculations. All that it has is the values memorized. Remember that cosine, sine, and tangent are just ratios. So they're a set value numerator, denominator that is always the case for a particular angle. Right? So like in 30 degrees, the sine is a half. It's always 1/2. So on my calculator, if I did 0.5, which is a half, and I went ahead and did sine, oops, I did it the opposite way. I'm going to go in inverse, but yeah, if I wanted to find the sine of a particular angle, 30 degrees is what I should have done. 30 degrees, and I'm doing the sine. It tells me that the sine of 30 degrees is 0.5. So all your calculator is really doing here is just having those numbers memorized. It just has it stored on the calculator, and when you're typing in those values, it's just going to give you that sine, cosine, tangent ratio as a decimal. So in this case, if I'm trying to find the tangent of 28 degrees, I'm gonna on my calculator, and again, if you're on one of those similar calculators, I'm going to go ahead and type in 28 first because I want 28 degrees. And then here on mine, I have to go into the trig menu, and I want to do tan. Now on most calculators, sine, cosine, and tangent are shortcut buttons. If that's not the case, check in with me, and I can help you figure out where those buttons are on your calculator. But especially sine, cosine, tangent, they're almost always, on a scientific calculator, a button on your calculator that you can find and just press directly. So on mine, I type in 28 degrees first, and then hit tangent, and I get that super small number, 0.5317, yada, yada, yada. So the reason I rearrange first is because I don't want to round this until I'm done. So if that's my set ratio, every single 28 degree angle has an opposite over adjacent ratio of 0.5317, yada, yada, yada. As you can see on the screen underneath, we're doing 15 times that ratio. So I'm going to go ahead, without changing anything up, I'm going to go ahead and just hit times 15, hit equals, and I get 7.9756, yada, yada, yada. And as usual, we'll just round it off to 2 decimal places. So in this case, 7.98. So 7.98 is my A value. I'll go ahead and put that over here, 7.98. Okay. If you're using, again, a graphing calculator, if you're using a 30X2, which is like the scrollable ones that I have on in the bin that you guys have available to borrow from me, you would just type in tangent, it'll open up a parenthesis for you, 2.8, and then hit enter, and it gives you that ratio. And actually for you guys, the nice thing is you could even just type that in directly, 15 times, hit your tangent button, 2.8, hit equals, and it'll spit out the 7.9765, whatever. All right, I still need my third side, and I do technically have two options for this. Because now that I have two sides of my right triangle, I could, if I wanted to, use Pythagorean theorem to solve for that third side. Right? I could do 15 squared plus 7.98 squared equals my hypotenuse squared. And that should give you a pretty accurate answer. It shouldn't be too far off, but it might be slightly rounded wrong. Because we know the answer that we just got, the 7.98, is not exact. It's close, it's really close, but it's not exactly the same as the actual side length of BC. It's a rounded answer. So I don't like using rounded answers. I would, again, rather stick with using values that are provided for me, that are given in my problem. So instead of using Pythagorean theorem, which, again, if you were really wanting to use Pythagorean theorem as a third value, like to find your third value, I'm not going to stop you from it, but just realize if you do have an answer that's slightly off from the exact answer because of your rounding issues and other stuff, you will lose a half point if it's rounded wrong. So it's just something to be aware of. It's possible, highly unlikely, but it's a possibility. But besides the fact that here I want to do an extra practice problem of this style, we'll go ahead and do it very similar method. So if, again, I'm looking at, now I'm finding side length C, which is my hypotenuse. If I know my adjacent, which is 15, I know my hypotenuse is what I'm looking for. My adjacent and my hypotenuse always work together in cosine, right? Cosine, ka, and so ka, toa, is adjacent over hypotenuse. So I'm once again going to go ahead and set up an equation, and in this case, the cosine of 28 degrees is equal to my adjacent over my hypotenuse, which is going to be little c. So now, this one a little bit trickier to solve because my c value is in the denominator, not in my numerator. So depending on how you want to look at things, if I'm trying to get the c out of my denominator and get cosine away from it, I'm going to have to be multiplying by c on both sides to get my c out of the denominator. So that's c times cosine of 28 equals 15. So then I divide by the cosine of 28 on both sides. And we get that c is 15 divided by the cosine of 28. So I'm going to have to, again, use my calculator to find the value of cosine of 28 and do 15 divided by that number. So once again, I'm going to go ahead and grab my calculator, pull it up here on screen, go ahead and clear that. So 28, I go into my trig menu, we're looking at cosine. So if you did that correctly on your calculator, which you should be trying it as I'm going through this in the video, if you do it correctly, you should get 0.882947 and then some other mess. So if I'm going to go ahead and do 15 divided by that number, so I could do it on my calculator, but again, keeping that same value, 15 divided by the cosine of 28, gives me 16.98855, yada, 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 yada. So 16.99 is my end value, because this was 15 divided by 0.88, yada, yada, yada. So C ends up being 16.99. And so we've got all three side lengths, we've got all three angles, so now my triangle is now solved. So I realized that was a tedious, very time-consuming problem, but it was really three problems in one. I had to find my missing angle, I had to find two separate missing sides. So it's a pretty extensive problem when you have to solve a triangle. All right, last but not least, a little word problem here. So box 4 here is an application problem. It says we're hiking near a canyon while standing at point A, which is the bottom right here. You measure an angle 90 degrees between B and C, as shown. So you look to the left, you see B, which is on your same cliff side, and then you turn exactly 90 degrees over on the other side, and that's point C. If you then walk over to point B and measure the angle is 76 degrees between A and C, which is labeled there in the picture for us. The distance between A and B is about 2 miles. They want us to use that to figure out how wide the canyon is between points A and C. So the nice thing here is that the picture is already given for us. They already set up the right triangle for us. In these word problems, setting it up correctly is the most crucial point. Obviously, that's the case if you don't set it up correctly. Even if you solve it correctly, you're not going to get the right answer. So you have to be able to visualize what's going on. A lot of Right Triangle Trig application problems are like ladders leaning against a fence, or like shadow length problems where the shadow is making a certain angle with the sun, and you've got the side, like the length of your shadow versus the height of you when you're trying to find that distance that the thing is traveling. But in this case, it's already set up for us. I've got my triangle, and if we want to rewrite it so it's not on a picture of a topographic canyon, we can do that to make it a little bit easier for us. But what it's saying here, and I'll use yellow so it's visible. This angle here, which is one of my two corners, not my right angle, but my other one, is 76 degrees. This little short leg here is 2 miles, and then we're asked to find this long leg, which would be the distance across my canyon from A to C. So without keeping the scale and everything, we've got this triangle that's 76 degrees. This is 2. This is what I'm looking for, X. So obviously it's not set up correctly. It does not look correct, but it might be easier for us to then see. Because once we have this set up, it's a problem just like up above in box 2. I have 76 degrees. This would be my opposite. This would be my adjacent. So I'm looking for the opposite, and I have the adjacent. So if I'm going to set up that equation, the tan of 76 degrees is equal to X over 2. So times 2 on both sides to get X by itself. So 2 times the tangent of 76 is what X is equal to. So I'll have to bust out my calculator again. Go ahead and clear that. So now 76 tangent, it ends up being 4.01078 something something something. So I have to multiply that times 2, and that gives me 8.021 yada yada yada. So 8.02 ends up being my final value there. 8.02. Actually, not that, because this is a word problem. So, and you guys know, if we're given units, we should be given units. So 8.02 what? 8.02 miles. Alrighty. So that is all I have for you guys for 9.1 day 2. The homework is down there at the bottom. It's page 467, 22 to 44, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.